As you all have been taught in the school that microphone is a device that converts sound waves into electrical voltage. Its working principle is just the reverse of a speaker. It's right, but the exact technology of the microphone is not that simple. Let's see how microphone evolved over the years. Story of the microphone begins as early as 1600. In those days, microphones were not exactly an electronic device, but an instrument for transmission of sound across some distance. It was an acoustic cup and string style microphone invented by British physicist Robert Hooke. It can be called as the first microphone.
In 1827, another British physicist, Sir Charles Wheatstone, created a device that could amplify weak sound and transmit over long distances. He was the first person to coin the term microphone. The first microphone was invented by Emily Berliner in 1876. Later, Bell Telephone Company bought his microphone patent for $50,000. 2 years later, in 1878, he created another microphone model with Thomas Edison. But the first microphone model, which is still used today, was a carbon microphone developed by British American inventor David Edward Hughes.
In the early 20th century, with the development of vacuum tube amplifier, new kind of microphone was invented by E.C. Vente, who was working at Bell Laboratories. This microphone was called a condenser microphone or an electrostatic microphone. During 1928 in Germany, George Newman and Company designed the first commercial condenser microphone. In the year 1931, Western Electric invented the first dynamic microphone. In 1964, researchers from Bell Laboratories, James West and Gerhard Sessler, developed the first electret microphone, which changed the entire industry due to its small size, higher reliability, precision, and its availability at lower cost. In the year 2000, with the growth of the mobile phones, new kind of microphones, micro electromechanical system (MEMS) were created, which is mostly used in mobile phones, headset, and laptops.
Let's have a look at different types of microphone. Carbon microphone was invented by David Hughes using carbon granules packed between two metal plates which act as a diaphragm. The basic principle behind carbon microphone is the fact that when the carbon granules are compressed, their resistance decreases. This happens because the granules comes into better contact with each other. When they are forced together with the high pressure, the pressure of sound causes variation in resistance between the plates, which in turn vary the current passing through the microphone. Emily Berliner and Thomas Edison improved carbon microphone and named as a carbon button microphone, which uses granules of anthracite coal packed between two electrodes. A thin metallic diaphragm attached with one of the electrodes. This microphone suitable for transmitting voice over telephone line, but not for radio broadcast and music recording due to high noise and limited frequency range response.
Later on, Western Electric produced the improved version of carbon microphone as a spring-mounted double-button carbon microphone. Also work on the carbon granules that can move around and touches the diaphragm. It became widely successful in the field of radio broadcast. The carbon microphone was widely used in telephone application because of their high output and hence no amplification was required. Advantages of carbon microphone include high output, simple principle and construction. They were also cheap and simple to manufacture. Its disadvantages are that it requires an electric power source for operation and has high background noise with frequency response. Condenser microphone. Edward Christopher of Bell Laboratories first introduced the condenser microphone. The condenser microphone had relatively weaker output as compared to the carbon microphone. It consisted of two parallel plates, each having electric charge on them. The vibrations produced from sound move the front plate, but the rear plate remains fixed, which causes the variation in the capacitance between the plates. As a result of the change in capacitance, there was a change in electric current in the circuit. It has better frequency response up to 6 kHz as compared to that of carbon microphone 3 kHz. With slight modification, the frequency response of the condenser microphone could be increased up to 15 kHz. The condenser microphone has much higher sensitivity and noise than dynamic microphone. A condenser microphone is not very robust as its internal structure is very delicate, so special care should be taken while using. Avoid using condenser microphone in a humid environment.
Dynamic microphone was developed by E.C. Vente and Albert L. Thurus at Western Electric. A dynamic microphone includes a moving coil and uses an electromagnet to generate the required amount of flux density. It is also called a moving coil microphone. Later improvement has been made by using a thin aluminum diaphragm and magnet made of cobalt steel alloy. It provides higher response up to 10 kHz. They were less noisy as compared to the earlier microphones and hence become very successful. A dynamic microphone is very sturdy and can tolerate rough handling. It is also able to handle high sound levels without distortion, which makes it very useful for certain musical instruments. It does not require an internal preamplifier. Dynamic microphone has a higher sensitivity. Crystal microphone is also called a ceramic microphone. These are generally low-cost unit, offer high output voltage at high impedance. These microphones were invented during the search for alternative that does not depend on diaphragm movement. Crystal microphone uses piezoelectric material to convert sound into electrical signals. These are certain materials that generate a potential difference across its end when the mechanical stress is applied, such as gallium phosphate. When the vacuum tube amplifiers were replaced by transistors, then crystal microphones were not able to adapt these changes and had soon paused out of the market.
Ribbon microphone consists of channeled aluminum ribbon suspended in the magnetic field. Due to motion in aluminum ribbon, there is a change in electric flux result into potential difference. The sound produced by ribbon mic is very natural and by design it is bidirectional, so it picks up sound from front and back, does not from sideways. It is used for recording different musical instruments such as electric guitar, brass, woodwind and drums. The modern ribbon microphone is robust and can be used for a variety of applications.
Electret mic. This kind of microphones are more widely used as compared to the other types of microphone. So let's discuss it in some depth. First, let's see what is electret. The electret is a dielectric material that has a quasi-permanent electric charge or dipole polarization. An electret generates internal and external magnetic field.
That means it is somewhat similar to dielectric material, but the difference is that dielectric have an induced polarization that is only transient, dependent on the potential applied on the dielectric, while dielectrics with the electret properties exhibit quasi-permanent charge storage and also dipole polarization. The term quasi-permanent implies that the amount of charge stored in the material does not remain the same permanently, but decays very slowly depending on the situation. And the decay time is normally much longer than the period over which the electret is in use. The electret material is a whole topic in itself. We can talk about them in the another video.
Electret materials are of commercial and technical interest. For example, they are used in electret microphones and copy machines. They are also used in some types of air filters for electrostatic collection of dust particles, in electret ion chambers for measuring ionizing radiation of radon, and in vibration energy harvesting. One of the most common types of microphone that are used in modern devices such as smartphone is the electret microphone. The electret capsule contains an electret diaphragm which makes a capacitor of variable capacitance and a JFET transistor module. The electret microphone JFET amplifier has a gate connected to a pickup plate. The source is connected to the ground and drain is connected to the output pin. This configuration is known as common source configuration, which requires an external power supply voltage VCC.
A fiber optic microphone converts acoustic waves into electrical signal by sensing changes in the light intensity instead of sensing changes in capacitance or magnetic field as with the conventional microphones. Photo fiber optics microphones are used in very specific application areas such as where the noisy environment is available. They are very useful in medical applications, allowing communication between radiologists and staff who are in the powerful magnetic field inside MRI suites. Other uses include industrial equipment monitoring, audio calibration, and measurement.
Laser microphone. These are shown in movie as a part of spy gadgets because it can be used to pick up a sound from much larger distance as compared to the typical microphone. A laser beam is aimed at a surface of window or other plane surface that is affected by sound. The vibrations of this surface changes the angle at which the beam is reflected, and the motion of laser spot from the returning beam is detected and converted to the audio signal.
MEMS stand for Micro Electromechanical Systems. These microphones are used in such applications where high sound quality, reliability and affordability are concerns. MEMS microphone is a solid state integrated circuit which can sense voice in the same way as ECM microphones. ECM microphone, it stands for electret condenser microphone. They are getting increasingly popular in modern devices such as mobile phones, tablet, laptop, smart TV, automotive voice recognition, gaming and remote controller, etc. Recently, crystal microphones are making their way back into the market. Vesper Technologies, a new microphone technology developer, has raised $23 million from some of the biggest names in the technology to finance the commercialization of its piezoelectric microphones. They are aiming to manufacture MEMS using piezoelectric technology. The current technology allows for smaller microphones that are incredibly sensitive, but the mic themselves typically don't withstand the wear and tear of the harsh environments.
Piezoelectric MEMS design replaces the diaphragm and backed it with flexible alternative that result in waterproof, dustproof, particle resistant and shockproof microphones that are highly reliable. These mics are to be used in future Amazon's Alexa devices. Here is an interesting question for you. Which device was invented first, microphone or speaker?
Thanks for watching this video. If you have any suggestion regarding the video, please let us know in the comment section. If you like this video, please hit the like button, share with your friends and don't forget to subscribe to our channel to get the updates about our latest videos.